All right, so now we're on the last section of this chapter, that's 7.5. You'll see some of the things that we are doing in the next video are very similar to some things that we've learned before, but instead of them being equal, they're now going to be proportional. But what we're going to use today is we're going to use the side splitter theorem, and then later on in video 3, we're going to use the triangle angle bisector theorem. Right? So that's what we're going to learn in this section: the side splitter theorem, and then the triangle angle bisector theorem. For this video, what we're going to be able to understand at the end of this is when two or more parallel lines intersect other lines, proportional segments are formed. So once we have these parallel lines that are intersecting other segments, we know that they're going to be forming proportional segments. All right, and remember, this is section 7.5 and is the end of our chapter 7, and this is broken up into 3 videos. So the first thing we're going to talk about is the side splitter theorem. And what this is stating is that if you have a side that is parallel to one side of a triangle, and they let us know that that side is parallel here by the arrows, and it intersects the other two sides, then it divides those sides proportionally, meaning that it will create a proportion that will work, that when we cross multiply, that they will be equal to each other. Right? So it will create two congruent ratios. So when we do this, remember, it's all about consistency. You can actually set this up in a few different ways. But here, we did XR over QR, XR over QR. So since we did this bottom portion here over the top portion, we need to stay consistent in our other ratio. So that means it would have to be the bottom portion SY over top of the top portion QS. Right now, this isn't the only way you can do it. You can set up any way you want, but just know that it creates a proportion. So we can set up two ratios that are equal to each other like we did here. All right, and then you do have a little bit of freedom in the way that you set these up. It's not just one way that you have to set this up. But the main thing that you have to remember is that if you have a side that's parallel to one side of the triangle and it intersects the other two sides, so it must intersect both sides, and it creates a proportion. And let's go ahead and solve a problem using this. So what is the value of A in the diagram at the right? So since we know that these two lines are parallel and this line intersects both sides of the triangle, we can create a proportion. So we can say A over A plus 4. All right, so I went top left over top bottom, so that means I need to go top right over bottom right. So then here we will say 12 over 18. And remember, there's different ways that you can set up these proportions. It's not just this way here. You could have did A plus 4. You could have did A plus 4 over top of A and 18 over top of 12. You even could have done A over 12 is equal to A plus 4 over 18. There's different ways you can set these up. It's not just one specific way. But once we set it up, we'll cross multiply to solve. So it'll be 12 times A plus 4 is equal to A times 18. We distribute the 12 in. So 12A plus 48 is equal to 18A. We'll subtract over the 12A. So then we get 6A is equal to 48. We'll divide each side by 6. And we get A is equal to 8. All right, so that is our final answer for this. All it said was ask for A, it didn't ask for any of the side lengths. So that was using the side splitter theorem in order to solve a problem. All right, and that's it for this video. These videos for this section are going to be fairly quick.